Section 13.4 is about the costs and advantages of home ownership, and the objectives are to explore the characteristics of fixed rate mortgages, and then we're going to talk about the characteristics of adjustable rate mortgages, and then to compute the closing costs associated with mortgages, and number 4, identifying recurring costs of home ownership. So first of all, what are fixed rate mortgages? Well, home ownership is really what a lot of people aspire to, and so here's the definition. So a loan for a substantial amount extending over a lengthy time interval, typically 10 to 30 years, for the purpose of buying a home or other property or real estate, and for which the property is pledged as security for the loan, is a mortgage. It's also called deed of trust or security deed. Some more definitions here. The time until the final payoff is the term of the mortgage, and then the portion of the purchase price of the home that the buyer pays up front is called the down payment, and then the principal amount of the mortgage, the amount borrowed, is found by subtracting the down payment from the purchase price. And so here's the detail on a fixed rate mortgage. As the name indicates, the interest rate remains constant throughout the term of the loan, and the initial principal balance together with interest due on the loan is repaid to the lender through regular, constant, periodic payments, typically monthly. And this process is called amortizing the loan. And the regular monthly payment needed to amortize the loan depends on the amount financed, the terms of the loan, and the interest rate, according to the formula right here. So here is the formula for the regular monthly payment, which we'll be using in a little bit here. So the regular monthly payment required to repay a loan of P dollars together with interest at an annual rate R over a term of T years is calculated as follows. So R equals P, the loan amount, times the rate divided by 12, all divided by 1 minus 12 divided by 12 plus R, raised to the 12 times R, or 12R power. And as I said, we'll be using this formula here in just a moment. So the first few examples are about finding the monthly payment of a fixed rate mortgage. And so here we have 6 different examples. And so here's the loan amount, the interest rate, and the term of the loan. Now, where the interest rates are like 5.5 or 8% or 9.5 or 5%, we can use Table 6. Now, Table 6 is on page 759. And what that tells you is the monthly payments to repay principal and interest on a $1,000 mortgage. For example, when we look at the first question here, where the loan amount is equal to $100,000 and the interest rate is 5.5% and the term is 20 years, so we look in table 6, and so we go to the interest rate of 5.5%, and then we go to 20 years, and so we find that for $1,000 a mortgage, the amount is 6.887. So that's per 1,000. So therefore, we need to multiply that by 100 because we have 100,000. So then the payment would be equal to $687.88. So 600, we move the decimal point 2 places over, so we have 687 point, we round it up to 89 cents. So there would be the regular monthly payment that would amortize the loan over 20 years. Okay, so we found this amount financed from table 6. When we look at the next example, where the loan amount is $23,000 and the interest rate is 8% and the term is 15 years, we can do the same thing. So in table 6, we go to 8% because that's the interest rate. Since the term is 15 years, we go to 15. And so we find that is per $1,000 is 9.55, 652. So that's per $1,000. So we need to multiply that by 23. And that's equal to $219.80. Now for exercise number 9, we cannot use table 6 because table 6 is only in steps of 0.5%. And so here we have 5.2% for R. So we need to use the regular payment formula that we looked at a moment ago. So in this case then, P of course is equal to 145,000, and the interest rate is 5.2%, so 0.052 divided by 12 divided by 1 minus 12 divided by 12 plus 0.052, and this expression in parentheses is then raised to the 12 times 25 because the term is 25 years. 12 times 25. And when you evaluate this expression, it is equal to $864.64. So it would be $864.64. And for number 10, it's the same thing. We need to use the formula because there's no entry in the table number 6 for interest rates of 6.3%. So again, it is the regular monthly payment. Let me just move this around here. So for number 10, the regular monthly payment R is equal to 95,000 times R divided by 12, so 0.63 divided by 12 divided by 1 minus 12 divided by 12 plus 0.063 raised to the 12 times t is 30, so to the 30th power. And when you evaluate this expression, then you find that's equal to $588.02. So $588 $1,488.02. Now for number 11, we can use table 6. So we look at the interest rate of 9.5%, and then we go over to 25 years, and we find the entry of 8.73697. And that is per $1,000, so we need to multiply this by 227.75 times. And that is equal to $1,989.84. So when we have these kind of interest rates, 9.5%, 8%, 9.5%, we can simply use a table. It makes it much easier. As you can see, the regular payment formula takes a while to evaluate, but it's just a straightforward calculation. And so then for number 11, it was $1,989.84. And for number 12, it's 5.5%. So that we can look up in the table 6 also. And when we look at the interest rate of 5% for 10 years, we find that that is equal to 10.606.55. That's per $1,000, and we have 195,450. So we need to multiply that by 195.45, and that's equal to $2,073.05. So $2,073.05. So as you can see, whether we use the table number 6 or if we use the regular payment formula, these numbers are pretty easy to compute. The next two exercises are about the amortization of a fixed rate mortgage. And so here we're to complete first one and the other one for 2 months of each amortization schedule for a fixed rate mortgage. And so for number 16, the mortgage amount is $112,000. The interest rate is 5%, and the term of the loan is 20 years. So we need to find, first of all, the regular monthly payment. That would be this one here, payment number 1, total payment. And so since this is 5%, 20 years, we can go to table 6 to find out what that is. And so when we go to 5%, 20 years, we find that is $6 and 5.59956 per 1,000. So we need to multiply that by 112. And because the loan is 112,000, so the regular monthly payment is $739.15. So that includes interest. Then now we need to compute the interest for the months. So interest for the months. And that's 112,000, the loan amount, times the interest rate of 5%, 0.5, and that's for the year, so we need to multiply by 1/12. And so the interest is then equal to $466.67. So that's the interest. and then the payment on the principal. So payment on principal is a difference between the regular monthly payment and the amount paid towards the interest. So in other words, we subtract from $739.15, we subtract the interest of $466.67, $466.67. So that's equal to $272.48. So we can fill in the numbers here, $739.15 for the total payment, $739.15, and the interest payment is $466.67. Of course, with all dollar signs. And then the principal payment is $272.48, the amount we just computed, $272.48. And now the new balance of the principal, new balance of the principal would be the original loan amount of $112,000 minus the amount that goes towards the principal, and that was $272.42. So in other words, well, not quite twice as much, but a large amount of the payment, of the total payment of $739.15, $466.67 goes towards interest, and only a small amount goes towards the principal. So therefore, the new principal amount is $111,000, $727.52. So that's the new principal, the balance, $111,727.52. So that's how you do it. You start with a regular payment, you compute the interest based on the loan amount, and the interest, and 1/12 because it's for 1 month, so that's the interest for 1 month. And then the payment towards the principal would be the total payment minus what goes towards interest, so that goes towards the principal. And then the new balance of the loan would be $111,727.52. Now number 17 is very similar. The mortgage amount is $143,200, and the interest rate is 6.5%. So this allows us to go to table 6, and we find that for this interest rate, 6.5%, in 15 years, the amount per $1,000 finance is $8.71107. So that's per 1,000. So we need to multiply that by 143.2. And that would be equal to $1,247.43. Next, we compute the interest. And that would be the loan amount of $143,200 times the interest rate of 6.5% times 0.065 times 1/12, because that's for the year and we want to know it for 1 month, and that is equal to $775.67. So that's what goes towards interest out of the total payment. So then the principal, the payment on the principal, payment on principal is then equal to 1,247.43, 1,247.43 minus what goes towards the interest, $773.11. So what goes towards the principal is $474.32. So let's fill in the amounts. $1,247.43, and the interest payment that month was $775.67, so it's kind of small. And then the payment towards the principal is $474.32. And then the balance of the principal, so the balance of the principal, I'm just going to write balance, would be equal to 143,000 minus the amount towards the principal, minus 471, I'm sorry, 471. That's a 1, not a 4. $471 and $76. Sorry about that. So 143,000 minus $471.76. So now the new loan balance is $142,728.24. So that is the new principal balance. 142,728.24. Okay, so now we need to do it for the next payment. And so now what we're going to do is we're going to compute the interest, but the interest is now based on the smaller amount, the new principal amount. So then the interest for the second payment, the interest is equal to 142,728.24 times the interest rate of 0.065 times 1/12, since it's for 1 month. And so the new interest amount is going to be $474 and 32 cents. So the interest for the second month is only $773.11, whereas in the first month it was $775.67. So now the payment on the principal payment on principal is simply the regular monthly payment of $1,247.43, $1,247.43 minus the interest of $773.11, and so that amount is equal to $474.32. So let's fill in the amounts. Of course, the total payment will be the same because it's a fixed mortgage after all. And then the interest was $773.11. And then the payment towards the principal is $474.32. And then the balance, the new balance, is equal to the old balance of $142,728 minus the amount of principal that we paid towards it, which was $474.32 right here, so that the new balance would be $142,253.92. So that would be the next entry here, $142,253.92. There you have it, $142,253.92. So if you were to do the third month, you begin with the same way. You compute the interest based on the new amount and proceed in the same pattern. But that was not the objective here. It was only for the first and the second months. And what you would observe is, of course, that the total payments remain the same because we have a fixed rate mortgage, but that the interest payments would decrease over time, and the amount towards the principal would increase, and then the balance of the principal would also, of course, decrease over time. So that over a, in this case, a 15-year time period, the amount would be fully amortized, which means it'll be all paid back. For the next two examples, we are asked to find the total monthly mortgage payments, including taxes and insurance. So here, the first one for number 21, the mortgage amount is $62,300. The interest rate is 5%, and the term of the loan is 20 years. So we can use table 6. And so when we go, let's just move it up a little bit here. So for number 21, when we go to table 6, we find that for 5%, 20 years, financing, the rate is 6.9956 per $1,000, and that's $62,300. So we multiply that by 62.3. So that's the regular payment, and that's plus. Then we have annual taxes and annual insurance. So that means we add 610 and 220 and divide it by 12. And so that's equal to 411.15 plus 69.16 for a total of $480.31. So the answer here would be $480.31. That would be the total amount. And for number 22, number 22 is quite similar, where we can look up the amount financed for $1,000 in table 6, so 6% for 10 years, and that is $11 and 0.10205. And since we are financing 51,800, we need to multiply that by 51.8. So that's a regular monthly payment. R plus then taxes and insurance, 570 plus 145 divided by 12, since we want to compute this per month. So that's equal to $575.09 plus this amount would be equal to $59.58 for a total of $634.67. So $634.67. So that's a dollar sign here. As you probably know, credit scores are important, especially when you want to take out a mortgage. And it turns out that if you have a higher credit score over the life of a loan, you can really save a lot of money because you get better interest rates. So here's an example of a $200,000 loan over 30 years. So the term is 30 years. And here's various interest rates given, corresponding to the credit score range. So when you're at 720 or above, you get a 4.5% rate, etc. And the lower your credit score, the higher your interest rate. So, and to really make it visual, what that means financially, let's compute the amounts that you save or that you pay over the life of the loan. So when you look at the first scenario, we can use the table number 6. We're looking at 4.5% for 30-year loan, and that amount would be $1,013.37. So that would be our regular monthly payment based on table 6. We multiply 200 times the rate based on 4.5% and 30 years. So that's our regular monthly payment, and we pay that 360 times, 30 years, and so that amount would be $364,813.20. And so how much was the amount? The amount was for 200,000. So therefore the interest paid over the life of the loan was $164,813.20. So we subtract the 200,000. So $164,813.20. Still quite a bit of money. Now, when we look at number 38, we cannot use table 6, so we have to use the regular payment rate. R equals P times R divided by 12 divided by 1 minus 12 divided by 12 plus R to the 12t power. Which would be, in this case, the principal is 200,000 and the rate is 0.04625 divided by 12 divided by 1 minus 12 divided by 12 plus 0.04625 to the 12 times 30th power times 360, because it's 30 years would be 360 months, so that's the regular monthly payment times 360, and so that amount is $370,180.80. So that's when we evaluate this expression and multiply by 360. That is equal to $370,180.80. So from that we subtract the principal of $200,000. That means the amount of interest paid was $170,180.80. So that's $170,180.80. Now for number 39, it's the same thing. We compute the regular amount, the regular payment. R equals the principal of 200,000 times the rate 0.0475 divided by 12 divided by 1 minus 12 divided by 12 plus 0.0475 to the 12 times 30 power. So that's our regular monthly payment. If we multiply that by 360, and that is equal to $375,584.40. And so from that amount we subtract the $200,000 principal to get the interest. And so the interest paid now is $175,584.40. So $175,584.40. And then for the last one, again this was number 39. And for number 40, well, let me just turn this paper around. So for number 40, we have the regular monthly payment of 200,000 times the rate of 0.04875 divided by 12, all divided by 1 minus 12 divided by 12 plus 0.04875 to the 12 times 30 power. And then we multiply that amount by 360 for 30 years. That's a monthly amount times 360 months. And that is equal to, that amount is equal to $381,031.20. From this we subtract the principal of 200,000. So this, the amount of interest paid, in this case, is $181,031.20. So $181,031.20. So as you can see, when you have better credit rating, the interest rates do make a difference. So here you have like almost over $16,000 difference between the credit score in this range versus 720 and above. So it pays to maintain a good credit score. So pay attention to these things, because eventually you probably may need a mortgage if home ownership is important to you, and then you'll be glad that you had a good credit score. So the next topic is adjustable rate mortgages, and even though a lot of people like fixed rate mortgages because the payments are predictable, there are sometimes reasons why an adjustable rate mortgage may be a good idea. And it starts out with a lower rate than a similar fixed rate loan, but the rate changes periodically, reflecting changes in prevailing rates. And what that means is that the rate can go up and it can go down. So you're basically hoping for the best, because it's obviously difficult to predict what the mortgage rates are going to look like 3 or 5 years from now, depending when the adjustment period kicks in. So there are a lot of different terms regarding adjustable rate mortgages, or ARMs, and one is the adjustment period, the time interval between the rate adjustments, like 1, 3, or 5 years. And then the index, that's the standard fluctuating average. That's the basis for the new adjusted rate, typically again 1, 5, or 3 year U.S. Treasury security rates, or national or regional cost of funds index. Then there's a margin, the additional amount added to the index by the lender, typically a few percentage points. And there's a discount, that's the amount by which the initial rate may be less than the sum of the index and the margin. And so that's an arrangement between the seller and the lender. And then there's an interest rate cap, so that the limits how much the rate can increase. That would be important. And there's a periodic cap as well, the limit on the rate increase per adjustment period. So an overall cap and a payment cap. So there are a lot of things. There's negative amortization. That means an increasing loan principal caused by a payment cap, preventing the payment from covering a higher interest rate. So in other words, all kinds of things you have to watch out for when you're considering an adjustable rate mortgage. And the negative amortization can happen when, due to the different caps, the payment won't cover the high interest rates. And what it really means, negative amortization, is that your your principal goes up instead of going down. That's what negative amortization means. And then convertibility features. It's a contractual ability to convert to a fixed rate mortgage. Sometimes that's designed ahead of time when this can happen. And so a lot of things to consider. There's quite often a prepayment penalty, and that's a charge that's imposed by the lender if the payments are made early. So there are a lot of things to consider, and again, adjustable rate mortgages may look very attractive, and again, there may be instances where that might be a good idea. Let's say that you live someplace for maybe 3 or 5 years. It may be a good idea to, in that case, get a lower interest rate to begin with, hopefully like 3 or 5 years, depending how long you're going to stay someplace. And in that case, any increase will not hurt you a lot, if at all. And but in general, if you intend to keep your property for a long period of time, going with an ARM, and if there's no convertibility, then that's probably not a good idea. So anyway, just a word of advice about this. Check it out and get all the pros and cons. I'm not a financial advisor. It's just my own experience has taught me that adjustable rate mortgages are to be treated very carefully. Next, we'll be discussing the effect of adjustable rates on the monthly payment. And so here, for each adjustable rate mortgage, find A, the initial monthly payment, B, the monthly payment after the first adjustment, and C, the change in monthly payment at the first adjustment. Okay, so for number 45, the mortgage amount is $175,000. And the ARM, the adjustable rate mortgage interest rate, is the index rate plus the margin. So that's 2.5 plus 2.5 equals 5%. And so now, and it's for 20 years, so we have the interest rate of 5%, and for 20 years, and so we can go to table 6. And for 5% for 20 years, we find that the rate is 6.59956 per $1,000 finance. So we need to multiply that by 175, and that is equal to $1,154.92. So that's the initial monthly payment, because it's with a dollar sign. Then when the adjustment happens, we are given the adjusted balance as $169,772.24. Now we need to compute that payment, so we use our regular payment formula. So it's a R equals P times R divided by 12 divided by 1 minus 12 divided by 12 plus R to the 12 times T power. So in this case, the adjusted balance is $169,772.24, and so the new rate would be 2.5% plus 4%. So R in this case, make a note of it, R equals 6.5%. So our rate now is 6.5%, so it's 0.65 divided by 12 over 1 minus 12 divided by 12 plus 0.065 to the 12 times. Now the time is no longer 20 years, but it's after 1 year, so time to the 12 times 19th power. And when you calculate this amount, it is equal to $1,298.51. So that's after the adjustment period, after 1 year. So that's for the B part. This was the A part. This is the B part. Now for the C part, we simply subtract 1,298.51 minus 1,154.92. And that is equal to $143. $143.59. So we subtract from the B amount 1,298.51, the amount from A 1,154.92, and so the difference, the change in monthly payment after the first adjustment is $143.59 increase. And that is why I said earlier, when you talk about the risk adjustable rate mortgages, you don't really know exactly what the adjusted index rate will be. So these are the answers for A, B, and C for number 45. For number 46, we have the adjustable rate mortgage at 3.2% plus 2.75%, so it's 5.95%, or 0.0595 for the rate, and so the payment would be $244,500 times the rate divided by 12, 0.059 divided by 12, divided by 1 minus 12 divided by 12 plus 0.059 raised to the 12 times 30th power, because they're 30 years. And so this amount is equal to $1,458.05. So that's for the A part. Now for the B part, the rate, the interest rate, is now is now 2.75 plus 2.6%. It's the margin plus the adjusted index rate. So now we're looking at an interest rate at 5.35%, 5.35%, or 0.0535. So now we compute our regular payment formula, use that. So we are told that the adjusted balance is $234,840.87. There it is. So then we have $234,840.87 times the rate divided by 12, so it's 0.0535 divided by 12, all divided by 1 minus 12 divided by 12 plus 0.0535 to the 12 times Now it's 27 years because it's after 3 years. 3 years after a 3-year adjustment period, so it's to the 27th power instead of 30 as we had in the initial one. So now that is equal to $1,371.53. So that's the answer to the B part. And for the C part, we simply subtract the amounts in A and B. So for the C part, would be $1,458.05 minus the amount here, minus 1,371.53. And that is equal to 86.52. 86.52. Now note that this is a decrease. In the previous example we had an increase, so here because the effective rate went down from 5.95 to 5.35. This was a 9 here. So here you have the answers for A, B, and C and how they were arrived. And again, you notice that this is just the regular payment formula that we discussed in the beginning. Regarding other costs relative to the purchase of a home, there are closing costs. And so I'd like to refer you to page 764 in the book. And loan origination fee and broker loan fee and lender document and underwriting fees and all kinds of fees. And they really vary from company to company. The title companies, they charge various amounts. And just be aware that there are closing costs. And some are negotiable with the seller and some are not. So you have to have a good real estate agent that represents you, or you have to be very good at negotiating these things yourself. And then of course there are recurring costs of home ownership. In other words, that you have to have down payment and cash, and that you have to qualify for the loan and making your monthly payments. And so besides property taxes and homeowners insurance and maintenance, there can be a lot of things. There's sometimes homeowners association fees, and again, maintenance can vary quite a bit depending on the type of construction, the age of the residence, and the condition, and it's a lot of things. And so you want to protect your investment, and so that is why you want to think about this twice and hopefully come out ahead and say, yeah, I like to do that. I like to own my own home, being aware of the additional costs involved. Now, again, example 7 on page 765 and 766 talks about the affordability of a home, and also when you look at the tax savings, they're included in there. So sometimes the tax savings can make it affordable to buy a home. But remember, you first have to pay for it and then take the tax benefits later when you file your income tax return. So, and again, that is now also in certain states, that varies whether or not you can do that or not. So I would not suggest that you buy your home based on the idea that you have some kind of tax savings there. It may or may not be the case, and that might kind of close when you have unexpected expenses. This could really hurt you. So anyway, home ownership has its rewards, pride of ownership, and if you take care of your property, you probably will increase over time. But at the same time, there are also some other things to consider, and you want to look into these costs and advantages of home ownership very detailed. And again, the rest of the chapter has some interesting questions in example 7 on page 766. And so just look at this and make sure you know what you're doing. That would be my recommendation. And this concludes section 13.4.